If you remember, in the last unit, we learned how to find the measures of arcs because the measure of an arc was the same measure as the measure of the central angle that intercepted it, or various other things that we learned. So what we're going to learn today is how to find the length of an arc versus the measure of the arc, which we already know, and area of sectors. So let's start off with some terms. Of course, we all know the distance around the circle is the circumference of a circle. And we know that to find the circumference, we would either do 2 pi r or pi times diameter. And we also learned in the last unit that a portion of the circumference is called an arc of a circle. So what we want to do now is learn how to find the length of an arc. Okay, so let's see what we got here. Arc length. What is arc length? It's just a fraction of the circle's circumference. So let's take an example here. Suppose you have a circle with a central angle measure of 60 degrees and a radius of 5. And we want to find the length of the associated arc. Okay, well, we know the measure of this arc is 60 degrees, and we want to find the length. So here's what we got to do. First step is we have to find the circumference of the circle. Why? Because the arc length is a fraction of that. So we find the circumference of the circle, and that's 2 pi r, which is 2 pi times 5, which would be 10 pi. We're going to leave this in terms of pi. So 10 pi inches is the circumference of the circle. Now, what portion of this circle is the arc? Well, it's, let me write this down. So we want to find the fraction of the circle, or the circumference, that the length of the arc is. So in other words, if the green is my total circumference, I can see that the red is a fraction of that. What fraction is it? Oh, well, it would be 60 degrees out of 360 degrees, right? And then I'd want to simplify that as 1/6. So I know that the length of the arc is 1/6 of the total circumference, which we calculated above as 10 pi. So 2 goes into that, 3, 5. So the length of that arc is going to be 5 pi over 3 inches. All right, and that's all we got to do, and that's what this little theorem here tells us, is that if you want to find the length of arc AB, you take its measure, find the measure, and then just multiply it by the circumference. So you really don't have to remember a formula. You just find the fraction that is the arc, and you multiply it by the total circumference. So we got some practice here. So how about if I do one of these, and then you can do the rest of the practice, and then we'll move on to area. All right, so the first one says, find the length of each arc in the next 3 examples. Leave answers in terms of pi. Okay, well, we know that the length is the fraction, which is going to be 70 degrees over 360 degrees, times the circumference, which is 2 pi r. So 7/36, it's going to simplify that. And the radius is 4, so that's going to be 8 pi. And when I simplify, let's see, 4 goes into that 9, 4 goes into that 2. So I'm going to end up with 14 pi over 9 millimeters. Okay, simple as that. Let's see what else we got here. I'll do one of these bottom ones for you because I know you don't like word problems. Let's do this one. The wheel of a compact car has a 25-inch diameter. So here's the compact car, 25-inch diameter. I got a pickup truck. It's got a 31-inch diameter wheel. So to the nearest inch, how much farther does the pickup truck travel in one revolution than the compact car? Well, how far is it going to go in one revolution? It's just going to go one circumference. So what do we need to do? We need to find the circumference of each wheel and then subtract the smaller from the larger. So let's do the circumference. I'll do compact car. So the circumference of the compact car is pi times diameter, which is 25 pi inches. Okay, the circumference of the truck is pi times diameter, which is 31 pi inches. So the difference is going to be 31 pi minus 25 pi, and that would be 5 pi inches. And let's see, does it ask us? Yeah, it asks us to round it to the nearest inch. So if I'm sorry, not 5 pi, 6 pi. 6 pi. 6 pi. So if I punch that into my calculator, I'm going to round that off to the nearest inch, which is going to be approximately 19 inches. Okay, you pause here and do the rest of these examples while I put the answers up for you. Okay, I did the second example problem here, just like the first. I know the fraction is going to be 100 over 360. That simplifies to 5/18 times the circumference. Multiply that, I get 35 pi over 9 millimeters is the length of that arc. Same thing in this one. I get 14 pi over 3 millimeters. Let me know if you have any trouble. Okay, I think I did the next one, the compact car and the truck. So the last one says I got this hamster. He's got a wheel with a 7-inch diameter, and as you know, man, those hamsters get on there and they just run and run and run. I'm wondering sometimes if they realize they're not going anywhere. Nevertheless, we want to know how many feet the little guy's going to go if he does 100 revolutions on that wheel. So what we know is we got to find the circumference, multiply it by 100. That's what I did here. I got 700 pi. But I got to read the question carefully. It says how many feet, and what we knew was the diameter in inches. So I got to change this to feet. So I divide by 12 and then I round it off, get 183.26. Okay, areas of circles. We know that to find the area, we got to do pi r squared. Pi times the radius squared. Okay, so find the area of a circle with a 32-foot radius. Area is pi times r squared. So what's 32 squared? 1024. And what do we got? Feet. So square feet. So everybody knows how to find the area of a circle. Okay, what if we want to find the area of a sector? The sector of a circle. So what is a sector? Here's what it looks like. Here's a circle. So it says it's a region bounded by an arc of a circle. So let's just take this. Here's an arc of a circle and the two radii to the arc's endpoints. So there's a radius, there's a radius. So this red section here would be a sector of a circle. All this here, it's like a piece of pizza. A piece of pizza is a sector of a circle. So next time you're having pizza with somebody, hey, say, I'll take a cheese sector of pizza. All right, so how are we going to find the area of that? Let's say you order a large pizza. It's got a 16-inch diameter. It's a veggie pizza. We cut it into 8 congruent slices. How do we know they're congruent? Because we said they are. That's how we know. So we got 8 of those there. How would you find the area? Oh, let's say you eat 2 pieces. How would you find the area of the pieces you ate? Well, let's say I ate these 2. Okay, well this one's pretty easy because how much in terms of a fraction did I eat of that pizza? I ate 1/4 of it, right? 1/4 of the pizza. So all I would need to do is find the area of the pizza, multiply that by 1/4, and that's how much I ate. So let's see, area is 1/4, no, sorry. The area of the whole thing, let me put a W there for whole. The area of the whole thing is pi r squared, which is pi times 8 squared. The diameter is 16, so the radius is 8. So 64 pi. So if I ate 1/4 of that, I got to do 1/4. The area of my slice is 1/4 times 64 pi, which is 16 pi, right? 16 pi, and what is it? Inches. So that would be square inches. Okay, but I want to show you down here. Let's say it wasn't so easy for me to determine if that was 1/4 of the circle. What I would need to do is I would need to think, what is this central angle here? Well, and I would see that that's 90 degrees, right? That would be 90 degrees, so the fraction would be 90 out of 360, which I knew because it's 2 pieces out of 8, so 1/4. And then I already did this part, so the area of the sector is just going to be the fraction, so it'll be the central angle measure divided by 360 times the area. That's how you're going to find the area of a sector, and I believe that's what it says right here in this little theorem 1012. I take the measure of the arc, well, which is also the measure of the central angle. Same thing, divide by 360, multiply it by the area of the circle. So here we go. Let's see if we got some examples. Yeah, what is the area of GPH? Okay, so we know the area is going to be, what is the measure of the arc is 72. 72 over 360, that's the fraction of the circle that sector is, times pi r squared. So what is 72 over 360? I believe it's 1/5. And 15 squared, you know what I'm going to do is I'm going to put 15 times 15 times pi. You know why? Because that's easier for me to simplify. So that'll give me a 3. So I end up with 45 pi centimeters squared. That's the area of the shaded sector there. Okay, how about this one? Why don't you pause here and you try to do this one, and then I'll put the answer up. Okay, this one was a little bit different because they gave me the area. So I went ahead and drew my picture, wrote my formula. I know the area of the sector is going to be 1/4 of the total area, right? 90 over 360. So then what I had to do is I had to plug in the area that they gave me to find the radius. Okay, so when I got my equation that has pi on both sides, I know the pi's are just going to cancel each other out, and then I end up with this little equation right here. It's a proportion, so I know I just cross multiply. R squared equals 144, so that means R equals 12. Of course, if we weren't looking for a length, it would be plus or minus 12. But in this case, we can't use the negative 12 because it is a radius, which can't be negative. Okay, how about a segment of a circle? A segment of a circle is a part of a circle bounded by an arc and the segment joining its endpoints. So here's what that looks like. So we got an arc bounded by an arc and the segment joining the endpoints of the segment. So this shaded end part is the segment. I know it seems like a line segment, but a segment of a circle is different. So what I hatched in there is a segment of a circle. How would you find the area of a segment? Well, let's think about it. What we would do is we would find the area of the sector first, right? Number 2, we'd need to find the area of the triangle. Area of a triangle, and then we'd have to subtract the triangle from the sector. Subtract the triangle's area from the sector's area. That seems simple enough. And this little key concept here is just what I said, only in pictures. You take the area of the sector, subtract the area of the triangle, you got the area of the segment. So let's see what kind of problems we can get into here. What is the area of the shaded segment? Okay, step 1, find the area of the sector. So the area of the sector is, I know 60 degrees is 1/6. And what do we know about this? Those two are congruent because they're radii. That means these two angles are congruent. And since this one here is 60, that means those two have to be 60. Yay, I got an equilateral triangle. Remember how to find the area of an equilateral triangle? I hope so, but we're not ready for the triangle yet. So let's do the area of the sector. It's 1/6 of the total area of the circle. So pi r squared, so I'm going to put 18 times 18. There's pi r squared. It's just much easier for me to simplify when I don't go ahead and square it. So that's 3 times 18, so 54 pi is the area of the sector, right? Area of the sector. Okay, now I'm going to find the area of this equilateral triangle. And I'm going to use this old friend I learned here a couple of lessons ago, the square root of 3 over 4s squared, which is the square root of 3 over 4 times 18 squared. And that's going to give me 81 times the square root of 3. Okay, I haven't put units on yet. That's okay. They'll all be square units. And then what do I have to do? I have to subtract. So the area of the segment is going to be the area of the sector, which is 54 pi, minus the area of the triangle, which is the square root of 3. I'm sorry, no. 81 times the square root of 3. And what do we got here? Inches. Square inches, that's the answer, because you know how much I like for you to leave things in terms of pi and simplified radicals. If you wanted to kind of get a feel for what that is and you punch it into your calculator, you'll find that that is about 29.35 square inches. Okay, let's see what we got here. We got 1, 2, 3, 4, 5, 6. 6 problems for you to do. These are pretty, a couple of them pretty challenging. Let me just get you started on the last one on this page. How are we going to do this? We're finding the area of a segment, right? So we got to find the area of the sector. So we'll do area of the sector, and that's going to be 120 over 360 times 36 pi. Okay, that's not too bad, right? R squared is 36. And then we got to find the area of the triangle. So the area of the triangle, what do we got here? Well, I'm not sure. I don't think it's an equilateral triangle. I could be wrong, but I can't just assume it. No, it's not. It definitely isn't. So what are we going to do? We're just going to use 1/2 base times height to find the area of this triangle. So let me draw this little triangle down here. So I got a little bit more room to play with. Okay, if this is 6, I got to find the height. So I'm going to drop this height, drop this altitude, and so if I show you this here, Okay, if that central angle was 120, then I know when I bisect that, this angle measure right here is going to be 60 degrees, right? See, I bisected this angle, so that gives me 60 degrees. So if this is 60, that means this little angle here is 30 degrees. And so that means, let's see, my hypotenuse is 6, which means my short side here is going to be 3, right? So that's the height of my triangle. That's the height of my triangle. This little piece right here is going to be 3 times the square root of 3 because it's a 30, 60, 90 triangle. So that gives me my base and my height to find the area of this little triangle right here. And then I'm just going to subtract. Okay, so I'll tell you that, you know what, I'm going to let you go ahead and finish that. I'm going to go back and pause here. I want you to work the rest of these problems. Give it your best shot. When you get finished, I'll have the answers up and you can check yours. Alrighty, this problem here, it was a matter of finding the portion of the circle that the shaded area is. So it's everything but 45 degrees. So I subtracted 45 from 360, got 315, and then I just applied my formula. 315 out of 360 happens to be 7/8 of the circle. So 7/8 of that circle's area is 56 pi square centimeters. All right, this one, I started you on it. So the area of the sector turned out to be just a third of the area of the circle, and a third of that area is 12 pi. The area of the triangle, we found the base and the height. We found the height down here to be 3. See, right there. And then the base is 3 times the square root of 3 times 2. So that would be 6 times the square root of 3, and when I multiply all that, I get 9 times the square root of 3. And of course, to get the area of the segment, I just subtract the area of the triangle from the area of the sector, get 12 pi minus 9 times the square root of 3. Okay, next page. What I want to do here is I want to find the area of, let's see here, I want to find the area of this sector. So I know that's 240. That's going to be 2/3. So that sector is going to be 2/3 of the circle, and that's what I did right here. The area of the circle is 81 pi, 2/3 of that is 54 pi. And then I've got a triangle just like I had in the previous problem. Had to find the base and the height. And when I drop this altitude here, that becomes, this little part becomes a 30, 60, 90 triangle. And that's what I use to find my height and my base. Plug that in here, and I get 81 times the square root of 3 over 4. And then I got to add these two this time. To get the total area, I have to add those two. Okay, in the next problem, I got to think, how do I get the area of this shaded portion? Well, it's a square, and it's got 4 pieces of a circle in it. Each one of these is 1/4 of a circle, and I can see that they're all the same size because they're marked. So what I really need to do is find the area of the square, find the area of the circle with that radius of 14, subtract the area of the circle from the area of the square, and this is what I get when I do that. Okay, finally, the last problem here, I gave you the answer. I didn't put down the steps because this is just a phenomenally great problem for you to figure out on your own. You definitely have the tools to be able to do that. So please give that a try, and if we need to go over the steps, if you can't get this answer, let me know, and we will certainly do that at the beginning of class.